Alright, so you guys are familiar with binary numbers. But binary numbers have a problem. Is that how are we going to represent negative numbers? We can't just use a negative sign because computers don't have negative signs. They just have ones and zeros. Well, let's notice the range of numbers that we have in an 8-bit binary number. It's going to be from 0 to 255. Now, can you think of any clever way where we can shift this so that there's half as many non-negative numbers and half as many negative numbers? So what we come up with is actually this most significant bit, this 128th bit. We can actually make it a negative 128 bit. And what that actually does is that shifts our range from 0 to 255 to negative 128 to 127. And this is called 2's complement. So let's see what this top number is now under the rules of 2's complement. Well, you're just going to do 1 times negative 128 plus 1 times 8 plus 1 times 2 plus 1 times 1. And the other ones are just going to be 0 times 64, 0 times 32, so that's why I don't write it. But this will just be negative 117. And the nice thing about 2's complement is that addition comes harmoniously. And for example, let's just do the same number plus, let's just say 2. Okay, now let's review how to do binary addition real quick. So it's just like decimal addition. So in decimal, if we had something like 9 plus 1, that would equal 10, right? So you'd have to set it to 0 and we'll carry over the 1 to the next place. Well, in binary, it's the same thing. The only difference is that 1 plus 1 is already 10, right? So we'll have to leave it at 0 and carry over the 1 to the next place. Same thing with something like ternary, where 2 plus 1 would be 10. And you kind of have to do the same thing. Alright, so let's add them together. And looks like we get negative 128. This is the 8th place, 4th place. This is the 1st place. Add them all up, and it looks like you do get negative 115. And now, since we can add positive and negative numbers together, we basically invented subtraction. And just a quick note is that anytime a number starts with 1, it's going to be negative because the magnitude of that most significant negative bit actually outweighs the sum of all the positive bits. And positive numbers are always going to start with 0 because you're going to be adding positive bits together, you're going to get a positive number. But there is some problems with 2's complement. And it's called overflow. Say we add 64 and 64 together. All right, we expect to get 128. But because we decided to make this leading bit represent a negative number, we actually get this weird thing where 64 plus 64 equals negative 128. And that is called overflow. So we can't actually fix this. It's just a flaw in the system. But we can detect for it. The general rule of thumb is if you add a positive and a positive number together, you somehow get a negative number. Well, that doesn't check out, so there's going to be some overflow. Right? Kind of like what happened up here. If you had a negative number, and you somehow get a positive number, well, that doesn't check out either, and there's going to be some overflow. But if you add a positive and a negative number together, there actually won't be any overflow because the numbers only reduce each other in magnitude.